I'd like to introduce our Chief Software Architect, Emerson Farrugia, and my co-conspirator in making this open mHealth platform a reality. Thank you. Enjoy your day.
So my recent foray into health is about a year old, but there's a lot of common themes which apply to all these verticals. Integration being one of them, which is what we're going to focus on today. And I also have an academic background in distributed systems and wireless sensor networks. So I intend to talk about a couple of things, just big themes. One is data interoperability, what is it, and why is it important to everybody in this room? And the Open mHealth platform, and how does it help with interoperability? So, health data, as all of you I'm sure know, is scattered absolutely everywhere. We have healthcare organizations who are generating data into their EHRs. We have research institutions who are running studies and surveys and putting that into their systems. Then we have company clouds and devices. So the phone in your pocket knows what time you woke up and how far you walked today. Fitbit is tracking your runs. And all this information is everywhere. And interoperability means moving this data around. So 3 typical use cases we've seen over and over again are that startups want to share the data from their devices that they're creating to drive their own growth. Research institutions want to combine mHealth data and data from the EHR so they can drive some population studies. And hospitals are more interested in data that their patients are producing so that they can actually monitor well-being and cut costs. The problem is, it's not just that data is absolutely everywhere. Data is also really different. So a couple of main ways they're different are formats and substance. Now, formats you can kind of deal with, but there's still a plethora of stuff out there. So EHRs have data in HL7. If you're doing research and you're doing statistical work, you need flat files to put that into Stata and R. All the public APIs we're familiar with, Fitbit, Withings, and so on, are producing either JSON or XML, but those 2 formats from 2 different places don't look anything alike. And then they've got differences in things like naming and time format. Things get even worse in terms of substance, though. So 2 different data providers will use different units. They'll handle time zones differently, and that's actually semantically meaningful, because saying that we're in Pacific time is not the same thing as saying you're in America, Los Angeles, or saying that you're UTC, I believe, -9 or -7, somewhere there. There are also differences in granularity. So you might be able to go to Fitbit and get your walking activity down to the minute level, which lets you run better analytics, but then another API will only give it to you at the day level. They group it differently, so you make one request to one provider to give you a nice chunk of information, but to the other provider you have to make 10 requests and kind of reassemble and jigsaw puzzle the whole thing. And then the worst one is when there's actually missing information. So we know that there are pieces of information we actually need, and if those pieces of information aren't there, it's very hard to work with that data. So the big question, in the face of all this, how do systems interoperate? Well, the general trend is if you want to work with data from multiple places, you bring it all into one place, you make sure you understand it, you operate on it, and then you don't become part of the problem. So when you provide that data to somebody else, you make sure it's meaningful. But how do you understand data? Now, I can talk about how we understand data in telecoms and payments and other health places, but I have to draw a completely different analogy, which strikes pretty close to home. So I'm not from the Bay Area, if you notice from my accent. I'm from a much bigger bay. I'm from the Mediterranean Bay over there. And I'm from Malta, which is a tiny little country. It's a little dot down there. And before I came here, I actually got a holiday, and I went to Sweden, which is this big country all the way up there. Now, as you can imagine, they're not the most similar of places. So for starters, Sweden is on the order of 170,000 square miles. Malta is about 120, period. We speak different languages. Maltese is a Semitic language. Swedish comes from Old Norse. We are very different in many different ways. And it also looks different. So Sweden looks like this, which is beautiful. Malta looks like this, which is not quite the same. And the food is different. So this is the lampuka, which is a Maltese fish, traditional. And this is strömming, which is herring, the common one. So I said that the languages are different. Now, the problem is that there isn't just this type of Swedish fish. There's also this type of Swedish fish, which is called surströmming. And the way they make this fish is they put the herring in a can, they put just enough brine so that it doesn't rot. They then bury the can for about 6 months. They open it, and they eat it. This is the only food I've ever heard of where you're not supposed to eat it indoors, because the smell will basically destroy the fabric of your building. So you really want to make sure you go to Sweden and you ask for the right fish. Now, that's a language problem. I am from Malta, and I don't speak Swedish. Swedish people don't speak Maltese. But we're both fluent in English. And the reason is that in Malta we get education in English in elementary school, as they do in Sweden. So somebody from a little tiny island in the Mediterranean can communicate perfectly well with somebody from a huge country in the Scandinavian states. And the reason we can do that is because we have a common language. So this is how we think you can help systems interoperate. You create a common language. That means, in our case, we're using schemas to structure data. And that really means creating templates or guidance or best practices on how your data should look. Now that helps you structure your data, but now you have to move it from one place to another. And you want to move it from one place to another in the same way. So we have an API, which we want people to implement to do that. Now, that's all great, that's specification. But we live in the real world, we're all pressed for time, and we need tools. So in order to get the specifications going, we provide free and open source tools to validate data, to pull in data from large and popular device manufacturers like Runkeeper, Fitbit, and so on. We have tools to store it and share it securely. We also have tools to move data in and out of EHRs, and we have tools to process and visualize data. And I will get through all these slowly, and there's a running use case with all this stuff, plus we'll talk about all this in the breakout sessions. So let's quickly get into the common language. So schemas help give structure to data. Basically, it's so that you can understand that data irrespective of where it comes from, and so that others can understand your data when it comes from your systems. Now, schemas are simply templates for JSON data. They're human readable, they support validation, and they're written in the JSON schema language. And this is what some data could look like. So this is a blood glucose measurement. It was taken sometime yesterday, and it's human readable. Corresponding to this data, there's also a schema which says, look, if you're going to talk about blood glucose, you need to say that the unit is milligrams per deciliter. You need to say what the actual value is, and so on and so forth. So that defines the data, but now we have to move it from one place to another. So we have a data point API, which is a simple, very simple, by design, RESTful API to manage your data. And it's secured with OAuth 2, so that it enables you to share that data back and forth. The cool thing about this is that when a new data provider implements that API, you're using mHealth, the mHealth API already, it's just a matter of pointing your code to somewhere else, and now you're pulling in data from a whole new source. That is not easy to achieve today. Now, to offer the API yourselves, you have two options. Either your developers can implement it, or you can run our storage component as an appliance, which is part of our tooling. So let's jump into tooling. I'd like to run this with a use case, because there are a lot of pieces which fit together, and we'll build up that use case as we go along, but I'd like you to keep this in mind. So let's say that you work in healthcare, and your clinicians want data to provide better care to diabetes patients. So we speak to clinicians all the time, and we know that the things they care about are whether patients are taking their medication, what their running blood glucose readings are, if their patients are sedentary or not, and their lab results. If you get all that information in one place and you can correlate it and make sense of it, you can provide better care to diabetes patients. So how do you build something like this? Because this data is coming from all over the place, right? Your medication information comes from some cloud system. Your lab results are coming from EHRs, and you have to assemble all this information. So this is kind of what you're picturing the clinician seeing at the end, but you have to build a system to support that dashboard. So the first thing you need to do is you need to store data. As I mentioned, there's a storage component, which is open source, written in Java, can run in Docker, so it's isolated from the rest of your system if you need it to be. And it's just an appliance which implements the data point API. So if you run this thing, it'll keep data. And it'll keep it in Mongo. And we're working on Hive or Spark. We're not quite sure which direction we're going in yet. So this is the use case I said I'm going to build up. That big box is your application. The first thing we dropped in there is a data storage component. Now, the cool thing about the data storage component, because it's open source, somebody else can use it too. So let's say that we want that medication information about pill dispensing, for example, to know if somebody's taking their meds. Well, we've spoken to startup companies who are going to use our data storage component and put the medication dispensing data into that component. So now your application not only uses one mechanism to store its own data, it uses the same mechanism to retrieve data from somewhere else, which is the box on the left. Now you want to integrate data. So you can integrate data from a few places. Let's start with the big existing APIs. So the Fitbits, the Runkeepers, the Health Vaults, Google Fit, so on and so forth. Those APIs are in no way standardized. So what we do is we provide libraries called shims, which take the data that's coming out of them, and we transform it and structure it in a way like the previous blood glucose measurement you've seen. That way you can get all this data to start interoperating, and you can work on it, and you don't care that it came from Fitbit or it came from Xilinx. And the way we do this is these libraries called shims, which run an appliance called Shimmer. So let's build our use case a bit more. We said that our clinician wants to know if a patient is active or not. Well, that data already exists. It just happens to be sitting on phones and watches and other mobile devices, and that data is getting synced to, for example, the Fitbit cloud from your phone. So you drop Shimmer into your application, and you can now reach out to those clouds, pull the data in, transform it, and put it in the data storage component next to the medication data. There's more information out there. So EHRs have lab results, and we want lab results to check, for example, the blood glucose information which has been gathered over time. So in order to reach into EHRs, we're working with Catalyze, who've open sourced their HL7 mappers, and they're here today, and they'll give a show and tell later, to get data into and out of the EHR, but working in our formats. When we add that to the system, we're now pulling in lab results, all into the same data storage place. HealthKit is a bit of an oddball. They don't offer an API like Fitbit and Runkeeper do. When your phone is tracking your steps, that data is trapped on your phone. So you need to get it out of there. And to do that, we wrote a library called Granola, which serializes that data. And serializes just means it takes the data, makes it available for transport, but you'll get a much better explanation of that later, and translates it into the mHealth format. So now you can actually write an app which sends data directly to the data storage component in their standard format. And again, the picture builds. Well, now that you've got all that data sitting there, you have to do something with it. So one use case we've seen is that clinicians don't really care about your steps. They care about how active you are. And that means calculating minutes of moderate activity. So to do that, we've started building processing components which reach into the data storage component, pull out data, crunch it, and put the results right back in. The idea is that you don't want to reinvent the wheel. So if we calculate minutes of moderate activity and that's open source, you don't have to do that. You can just use the same component and drop it in. And sitting there on the bottom right. Once you have all this data, you need to show it to the clinician, and that's visualization. So we have a whole breakout dedicated to visualization, and this is our final goal, and there it was. And that's the full picture. So again, I ran through that. There's going to be more talks about it. But let's talk a bit about the underlying technology here. So as I said, it's open source, and that really does matter here. You're talking about health data. You want to know how that data came to be, what it came from. And if there is a transformation, you want to be able to look at that transformation and see, is it right? Do I agree with it? Are they making assumptions which I don't agree with? So it's critical that it's open source. We use GitHub for source control. We love pull requests, And this is all about you guys. I mean, we need a community of people to contribute so that this ecosystem grows. And to do that, we've written this stuff in mainstream technology. So there's Java for the backend stuff, HTML, CSS, and JavaScript for the front end. And the reason we did that is partly because that's what we're good at, and it doesn't make sense to write something in a language you're not good at, but also because it's mainstream enough that we think enough people can look at it, understand it, and if need be, change it. We use Docker extensively to provide isolation, so that if you already have an existing system, you don't have to mess with it necessarily to get this stuff up and running. And because there are a lot of APIs in between the different pieces, if you need to use another language, go for it. You just implement the API and you're ready to go. So just a few final words. What we've seen here is all capability. It's all tooling. It lets you do stuff. But we can all do something that matters with that capability. We can improve patient care. We can increase personal well-being. If you're working in the healthcare industry, you can cut costs. And most importantly, we can innovate. And we can build new things without having to recreate all the tooling that goes into that. So whatever your goals, I think a common language and our open source tools can help you get there. And over the course of the day, we'll be trying to send that message across. Thank you very much. Any questions?
Thanks. Yeah, just wonder, is there a test environment we can try it online right now?
Right now, because it's all on Docker, there are instructions to get up your own test environment. Usually, if you're pulling data from external providers, you need to set up accounts with them. So it's easier, actually, if you run it yourselves in many cases, depending which part of the ecosystem you're using. But it is quite simple to get this stuff also up and running on EC2. So at this point, there's nothing pre-packaged for you, but it's like one button, hopefully, to get it up.
Or is there like an online document? I think you have something on the GitHub, right? So
Yes.
Wonder if you have instructions there for us to assemble all the components
Yes.
that you mentioned. Okay, all right. Thank you.
Sure.
Granola, is that actually available on GitHub at this point?
Yes, it is released. We actually had 2 releases so far. The first one just took the Granola, the HealthKit data, which we have these standard schemas for. But then we realized some people in the short term would want to just get all the data off the phone. So Chris wrote mappers into generic schemas, so corresponding to the basic HealthKit data types. So you can actually pull all the data off the phone right now. And over time, we'll standardize the remaining set of it, but it's all up there. Hi.
Once you aggregate the data, as you pointed out, does the issue of releasing it, getting it out of there with consent come up? And are you thinking to provide tools to allow that to happen?
The way we're doing it so far, I guess it depends on the different industries. The first case we're doing it is we want the data to really belong to the patient. So we're currently using OAuth 2 because that's a way to get the patient to explicitly approve authorization for one party to get access to their data from another party. And over time, we'll look at different options in different parts of the healthcare industry.
What are you doing about identity discovery? In other words, when you go out to that EHR, how are you identifying which data set to pull?
That's kind of a level up. So that's at the application level, because different EHRs can identify differently. And the important part, so the platform, if you're running these tools, you've got a concept of local identity. The EHR has a concept of local identity, and there's something at a higher level which has to reconcile those two.
Just a quick comment on the consent and authorization piece. John Wilbanks, Sharon Terry, Dixie Baker are working together at the Global Alliance for Genomics in Health to develop micro-consent with type binding that will fit very nicely into this scheme. So I think there's a lot of opportunity with the open source work that they're doing for the Global Alliance to extend the work that you're doing very conveniently.
Very good. All right. Thank you very much.